Hi guys, so today we are solving this problem called maximum product subarray. Let's read it. Given an integer array nums, find a subarray that has the largest product, return the product. The test case are generated so that the answer will fit in a 32-bit integer, right? So we've been given this array and we need to find the subarray which has the largest product. So for example, the first one, 2, 3, minus 2, 4. In this, if we see, we can take 2, right? And then multiply and take this one. So 2, 3 is 6, that is a subproduct. And then if we take another one, so 2, 3 into minus 2, again, that would be minus 12. And if we take everything, that would be 2, 3, minus 2, 4, right? So minus 12 into, that will be minus 48, right? And similarly, if we go and so if we see that is the maximum product subarray is the 6, right? And that will be our answer and we'll return that, right? And for example, if we take a scenario like minus 1, minus 2, minus 3, right? In this case, if we see the minus 1, minus 2, if we take just these two, it is 2. Then if we take everything from here, minus 1, minus 2, minus 3, that will give us minus 6, right? But if we just take this one, right, minus 2 and minus 3, that will give us 6, right? So maximum product is 6 here, right? Maximum product subarray is 6. So in those cases, we need to know like the subarray from the right also. So if there is any negative number, we need to know that the subarray is possible from the right as well, like right to left, right? Not just iterating from left to right. From left to right, it would be simple, right? Just taking two elements and adding the next element and keeping a max. That's actually the Cadane's algorithm, right? Which is to store the max value at each step, right? At each step, you store the max product value, right? And yeah, you just keep on taking elements from it one by one, right? And just keep on adding to the max product, you know, basically the value there in that variable, right? So that is possible for left to right, but you also need to do it from right to left, because if there is something like an edge case like this where you have two elements which are from right to left, which we need to multiply and add it, we'll need to consider that as well. So yeah, we'll do the cadence algorithm and it will be a two pass where you'll be iterating from left to right and also right to left and maintaining a max product and just returning that value, right? So let's get to the coding part in order to understand this a bit better, right? So let's get to the coding part. So first of all, we'll maintain a max product, which will be basically int minimum, initialized to int minimum. And then I will maintain a product integer to just use it as a multiplier. And then I'll just iterate from left to right. So nums.size plus, right? And here I'll have product equal to actually multiplied everything from nums of I, keep on adding that and actually update the max prod is equal to max of max prod, comma prod, right? And eventually, if prod product basically becomes 0, then also you need to initialize it with 1, right? And yeah, that keeps on happening and max prod is updated. Similarly, you will iterate from nums.size minus 1, I is greater than 0, I minus minus. From there, and you will say prod multiplied by nums of I and max prod equal to max of max prod and prod. And if prod equal to 0, then prod equal to 1, and you need to initialize the prod to 1 here as well. Like if it becomes 0 here, right, you need to make sure that at the end of it, it becomes 0. You need to make sure it's reusable for iterating from right to left as well for that pass, right? And in the end, you're just returning the max product value, right? So let's run it to see if everything is working fine. Cool. I hope you guys understood the problem. Thank you so much.